A rocket engine expels an amount of gas delta m at a speed v sub b. What amount of momentum does the gas contain? Well, since momentum, right, is equal to mass times velocity, but in this case, we're talking about expelling an amount of gas that for some reason has been called delta m. I think it's going to be called that because we'd eventually like to relate what's being discussed here to the rate of fuel burn in the sense of mass burn, like mass per time, but we're not there yet. So in that sense, maybe this would be the expression I should write. Maybe I should say that this is, I'm going to put a little subscript here for clarity perhaps. This is the momentum of some amount of exhaust corresponding to a mass delta m. So I think that's the answer we're going for here. I'm collecting this answer along with the answer to the previous question so that when we see how we can take sort of these things and put them all together, we'll see how things make sense. And it's interesting to note, I mean, I answered this. Is it correct? I use a little different notation there, right? So it says there, it's saying that this is delta P for the gas. And I think the interpretation is if we're tracking momentum changes, the amount of momentum in some amount of gas that has been expelled in the rocket engine, that really is like a change of momentum, right? So that's why we're calling it delta P gas. So I'm going to change it to that. It's also interesting to note that in the answer it says exhaust velocity times delta M. That's really the same as the answer that I gave. It's just that multiplication being commutative, that is just expressed differently. What I'd like to do is I'm going to move this one up here with these other results because I think that's the one that we're going to want to use, and then I'll get rid of this for the next example.